in this example, we'll try to sketch a possible graph of the function that satisfies the following. Sketch a possible, this is a good test question, by the way. And when I say this is a good test question, usually I mean that. The following condition, okay? 1, f prime of x is positive on the interval negative infinity to negative 1, right? And f prime of x is negative on the interval 1 to infinity. 2, f double prime of x is positive on negative infinity and negative 2, and on 2 to infinity. Okay, f double prime of x is negative in between, in other words, on negative 2 and positive 2. Okay, 3, the limit, remember limit of f of x when x approaches negative infinity is negative 2, and the limit of f of x as x approaches positive infinity is 0. Okay, so we need to satisfy 3 sets of conditions. So how we approach this thing? Well, I'm looking at possible intervals, and I'm looking at first where we have information about the first derivative, and I see that there is an issue. Something happened when I go between negative infinity to negative 1. I'm missing something. What am I missing on the first derivative? It said positive negative infinity to 1 and negative on 1 to infinity. So I don't know what's in between. Okay, so this would be a good starting point. Let's look at what happened between negative infinity and negative 1. Okay, so this is negative 1, and what happened between 1 and infinity. Okay, one thing I know that if I'm looking at the limit, so this is negative 1, this is 1, 0 will be right here. Okay, so this is y. And now the graph itself I'll do in blue. All right? So I know that when I go to negative infinity, I'll go to negative 2, so I'm somewhere here, going to negative infinity. When I go to positive infinity, I'm 0, so I'm right here with the function. So that's all I know, and I know between negative infinity to negative 1, I'm decreasing. I don't know what happened after that. Okay? I'm increasing. And I know that I'm decreasing as I go from 1 to infinity. So let's say this is where I'm decreasing. All right, so this is the information that I was able to get from this first derivative. Tells me where the function is increasing, where the function is decreasing. Again, as I go from left to right, I start at negative 2. So this is negative 2 right there. And I go up at I'm increasing until I get a certain point. I don't know beyond that. And as I go from left to right, I'm going down from positive 1. I don't know what's the value of y here, but I know that I'll end up at 0. Now I'm looking at the second derivative. And I see the following, that the function is concave down. Actually, you know what? I need this point to be -2 and +2. Okay? The function is concave down, up, is positive, or -∞ to -2. That's why I wrote it like so. So this is concave up. Okay? From negative, and concave up from 2 to infinity. So I did satisfy the second derivative required. Also, I'm looking here in concave down from -2 to 2. So in other words, here I have something that like this. But remember, the first derivative tells me that from 1 down, the function is 1 on, the function is decreasing. So partly I have some sort of, right here, I have some sort of a local maximum, and I'm going down like so. So here, what happened, I satisfied two things. I satisfied concavity down from -2 to +2, but also I satisfied the fact that from 1 to infinity, the function is decreasing. Okay? Let's see, did I not satisfy anything here? I think I satisfy everything. And we can check. Do we have f prime of x is positive on -∞ to -1? Check. Right? We go all the way to -1. Do we have f prime of x is negative on 1 to infinity? Check. I think everything else is checked. Okay, my time is up. You can see that I satisfy f double prime is positive on -∞ and -2. So we have an inflection point right here, change of concavity. Union 2 to infinity, checked. F double prime is negative on -2 to 2, checked. So we have relative max at x equals 1. Okay, guys.